I do.
All right, so 4.8 applications. Usually when we see applications, it's word problems. I think there's a couple on this one, but it really isn't. It's not word problems. It's just now all the stuff we've been doing, they're gonna make it an equation, and then you'll pretend like you enjoy it. So now we're gonna have equal signs with these. Now the good news is if you can factor, this goes pretty well. Okay, if you can't factor, don't do this section until you can do it with some efficiency. Okay. Not necessarily, you don't have to be a master at it. I mean, if you are, that's good too. But the reason why that is because what we're going to do is we're going to make all of the equations equal to zero. They may not start out equal to zero. The first ones will, just to get us started. But eventually they're not going to equal zero. We're going to force them to equal zero on our own. So we're going to take the numbers into our hands, and we're going to take control of them to do what we want. Well, so yeah, the equation, it actually has to equal zero. So it's not just a goal, it's kind of has to be that way. But this zero factor property right here, it's saying A and B. Think about it like this. So let's look at what this means, okay? A times B, which they may not be just individual values, they could be binomials, which we've seen, right? After they've been factored. Anything times zero is zero, which is good news. Because if I can make this binomial, which it'll eventually be binomial, if I can make it equal to zero, then I don't really care what happens to the b. Because anything times zero is zero, including zero. If I can get this one as well, which eventually it'll be a binomial, if I can get this one to equal zero, then the whole thing ends up being equal to zero, okay? So what we do is we end up taking these two factors, which are usually binomials, and then setting them equal to zero and solving them as separate equations. That will tell us the values of x, which if you were to replace into the original equation, of course, this is after factoring, right? Usually. So if you go back to the original equation and then solve these two binomials for zero, then you can replace those numbers into the original and you get zero, and it's great. Sometimes if it's squared, then you only got to do it once, which is kind too. But sometimes A and B are, that's what I was talking about. Polynomials, talking about binomials specifically. A quadratic is a polynomial with a degree of 2. I don't know why that's important. Oh, that's why. Because if it has a degree of 2, usually that means that you're expecting 2 answers. If you see that the degree of the polynomial is 3, expect 3 answers. Expect it. It doesn't have to. Sometimes the answers actually repeat, and so you end up with only 1. It's just a maximum number, right? So if it was a degree 4, you can expect 4, and then so forth. I said too much there, but I had fun doing it. So on this one, here's my 2 factors, right? So I'm going to start with this first factor, x. Okay, so here's the thing, is if I could make that x equal to 0, I don't really have to solve this equation. I just found a value of x that would make the whole thing equal to 0, and I'll prove it. Okay, so the original equation, x times x minus 2. I won't do this checking too often in this part, not at least by hand. So I said I'm going to replace the x's with 0, right? So this x is 0 and this x is 0. And I know 0 times 2, I'm doing this the long way, but just to kind of prove a point, 0 times negative 2 is still 0. 0 times 0 is true. Okay, so that tells me right there, boom, I found one solution. And it is a solution because when I replaced the x with 0, it made it true. The other factor was this x minus 2. So if I could get that x minus 2, and I'm creating a new equation, it's separated, but it's focused on this binomial, right? If I could get that to equal 0, it would still make it true, right? And again, I'll check just pretty much on this one, but right here I'd have to, not everyone needs to do this, I know, but I am. So I'm going to drop the x. I zeroed out my minus 2. X equals 2. That should be a solution, but will it work? Well, the original equation was x times x minus 2, and it should be equal to 0, right? But now we're going to replace both x's with positive 2. Okay, so 2 times 2 is 0. This should equal 0. 2 times 0 is 0, which does equal 0. That's true. And now I know I have, in fact, found another solution. So we get 2 solutions on this, 0 and 2. And we checked them. Both of them are solutions. We checked in the original equation. Always check in the original equation. Use a calculator if you need to. So it's a fine way to check, but we good. Now, before we go to the next problem, do understand that this would have started, usually it's going to start out as something like this. It's going to say something like x squared minus 2x equals 0. Okay, so it was already factored for us, but in the future, do expect to do some factoring. Of course, this was just the greatest common factor, but they did it for us. It's a nice way to start out. Polynomial equations by factoring. Write an equation in standard form. That's ax squared plus bx plus c. I'm not worried about that, okay? Just, we want the equation to equal 0. If you find that you have like 3x squared equals 5x plus 2, you got to make one of the sides equal 0. Doesn't matter which side, just one of them, okay? Once you get it equal to 0, then you're going to factor the polynomial completely. That includes greatest common factors and also factoring by grouping, or, you know, one of the other strategies, the difference of squares, that kind of stuff, okay? Set each of those factors equal to 0, which is kind of what we just did on that last problem. Solve the resulting equations, and then just make sure you check in the original equation. And then on that last slide, I actually wrote down what I was checking. In the future, I'm just going to use this because it's convenient. So it's a calculator. Let's see what an example looks like. Like I said on that last one, we would have had to do some factoring, right? Equals 0. That's a problem. We're gonna force it to, though, right? So I'm going to go into this, and let's force it to equal 0. So for me, I'm going to make it equal to 0 on the right side, right here, okay? So that means the 24x, I need to force it to become a 0. Now, since I'm going to force it to become a 0, this goes back to principles of equality. If you're going to make zeros, that means you're going to either use addition or subtraction principles of equality. Multiplication and division principles of equality are for making ones. This is a 0. So how do you make a 24x a 0? Just subtract 24x. Okay, now on the left side, I'm going to actually put it in the middle, minus 24x. That means I'm not going to combine it with 16x squared because it's not a like term with 16x squared. It's not a like term with the 9 because that's just a constant. So what I now have on the left side is 16x squared minus 24x and then plus 9. And why did I put the 24x, negative 24x in the middle? Because it goes back to that format that we've been seeing when we factor trinomials like this. Okay. Now, this one's actually going to give us kind of a break because I look at 16 and I look at 9, right? I look at the two ends right here. Both those are perfect squares, which means that right here, I could just make that 16x squared a 4x to the power of 2. And then the 9, I'm going to make that a 3 to the power of 2. Now, we still need to check, right? We still need to check. So the 24x, is that 2 times a, which is 4x, times the b, 3? It is. 2 times 4 is 8, times 3 is 24. I don't really care about the minus sign right here because that just tells me what sign is going to go in between the two values in my binomial, right? But my two values are 4x and 3. Now, if you factor this by grouping because you didn't notice that it was a perfect square trinomial, don't worry about it. You should get the same exact binomial to the power of 2 right there. Well, in the past, we were able to finish and then feel good about what we just did. But now we get more work to do because it's so fun. So we're going to take that. By the way, I don't have to do this twice because you're going to get the same answer, right? It's just squared. I mean, you're welcome to do it twice, but you'll see you get the same answer. So I'm going to take that 4x minus 3, right? And I'm going to make it, this is the inside of that parentheses. If I could make it equal to 0, I'll get a true statement from my original equation, which is what I want. I probably need more space, though. So right here, let's figure this one out. Oh, what the heck? So plus 3 on both sides. I'm skipping some explanation. Hopefully that's okay. But my 4x I can drop, which now equals 3. And then last of all, I'll divide both sides by 4. And so it looks like x in this case would equal 3/4. Now, again, if you separated this into two separate binomials, you'd be solving the same equation twice, which I don't want to do. So I'm not. But I will check. Okay, so I say, I'm going to go back to the top here, and I'm going to replace the x. See if it'll let me do it. The x I'm going to replace with 3/4, but there's two x's, right? So 3/4, and I'm going to put a question mark over the equal sign to see what I get. Okay, so in my calculator, I got 16 times 3/4 to the power of 2 plus 9 equals, and I get 18 on the left. And then 24 times 3/4 is also 18. That's a true statement. Yeah, it was the x was the 3/4 was squared, but this is true. So I found that by replacing the x with 3/4, I did get a true statement, which makes this my solution. Again, there is technically a second solution right here, but it's the other 3/4. There's a reason for this. It's graphically, but we don't want to get into the graphs yet. You know what? I'll demonstrate this because the technology is going to make it easy. But I can do this twice because, boom, there it is. I did it twice. But I got the same answer twice, you know what I'm saying? So it does have two answers, just the same answer twice. I just don't want to list it twice. Like if you put 3/4 in the assignment, then 3/4, it'll be like, what the crap? And then you'd get marked points, which we don't want. All right, you're going to see problems worded like this. Solve for w when f of w equals 0, where this is, they're not really saying it's f of w, but it is. So even though they're not saying it, you could write it in if you wanted to. F of w equals this, right? But up here it says, hey, make your f of w equals 0. So here's my f of w right here. So let's take it and replace it with 0. So you see it just kind of formulated an equation. It was kind of a long way around, and they could have started with this equation, but they made us do it. Stinking jerks. Hey, now I would look for any greatest common factors to take out of this, but I don't see any. 15 is not a perfect square either, and neither is 3, so that doesn't help us with perfect square trinomial business. So I'm looking for factoring by grouping on this one. So I'm going to take the leading coefficient 15, and then in this case, the constant, I'm going to show it as -3. When I multiply this, I get -45. Now I need two factors of 45 to add up to 4, positive 4 specifically.
Plus 9 to minus 5.
Yeah, that's correct. So we're going to use a +9 and a -5. When I add those together, I do get 4. So I'm going to take the 4 w's and split it up into those two values as 9 w's and a -5 w's. Okay, so now I've got, well, 0, but 15w squared. That's a +9w minus 5w minus 3. And yeah, I will show the equals 0. But some students don't like to show this yet just because we're kind of focused on our factoring, right? So you don't necessarily have to worry about the equals 0 yet. We will, but not yet. So from here, we're going to let's factor this first group, this pair. So it looks like I know I can factor out a w from there, but also it looks like I can factor out a 3. So 15 divided by 3 is 5, 9 divided by 3 is 3, positive. And then we took out a w from the first term and the second term. This w factored out as well, but that leaves us with no more w's, okay? Now we'll go to the second set, and I got a -5 coefficient to start. So I know I'm going to factor out a negative. Oh, I don't see anything I can really factor out, so I do need a 1 right there. And then I'm left with -5 divided by -1 is 5. That's how many w's. -3 divided by -1 is +3. And you can see, again, our binomials that are left match, which means that we can take those two binomials out and factor them out of what is going to be what's left over from that binomial, which would have been 3w and -1. Okay, now again, this still does equal 0. And in the past, right, for this whole unit, at this point we would have been done, but we got a little bit more work to do. We got to solve these two by forcing them to equal 0. So let's do that. So I'm going to give myself more space first. But I'm going to start with the 5w plus 3. If I could get it to equal 0, then the whole thing would equal 0. And some students say, well, this part wouldn't be 0. That's true. It doesn't matter because this one is. You're going to have 0 times something. I really don't care what this is. It's going to be 0. Okay? So let's go ahead and solve that. principles of equality, right? So minus 3 on both sides. Drop my 5 w's, which equals now negative 3. Looks like we're going to end up with a fraction. Then divide both sides by 5. So w, or 1w, equals negative 3/5. Okay, now, if you're, I'm not going to do it, but if you were to replace these w's with negative 3/5, make sure you put this one in parentheses, because if you don't, the calculator is going to interpret it differently. It's going to interpret it incorrectly. Make sure you put this w here in parentheses when you put it in. But if you do, if you replace these two w's with negative 3/5 in parentheses, you're going to get 0. It checks off. Okay, now that's one of our solutions, but we expect the other binomial, 3w minus 1, if we could make this one equal 0, it should also work. Okay, so let's see what we get. So right off the bat, we'll add 1 to both sides. So that zeroes out. 3w equals 1. Then divide both sides by 3. And it looks like w, in this case, equals 1/3. Okay, now again, if you go back up here, replace your w's with 1/3, boom, you get 0. And then you get, you find that it would be a solution. Okay, so on this one, we need to make it equal 0. It is not yet, but we're going to make it equal to 0, just like we saw, what was it, 2 problems ago? So, to do this, there's a couple different ways to do this. You could actually subtract 23w and subtract 5 from both sides. I prefer to do it just once. So I'm going to subtract from both sides. Sorry, not subtract, but I'm going to zero out the negative 12w. I'm going to add 12w squared to both sides. Now I'm putting it here on the left, plus 12w squared, putting it on the left of the right side of the equal sign. But again, I just don't want that to get confused with 23w plus 12w squared, that I can combine those, right? But on the left side, I do get 0, which is what I want. But now on the right side, I want that 12w squared term first, just so it kind of maintains that same format that we've been seeing. And then we have a positive 23w and also a positive 5. Now, if I had some perfect squares in here, you know, we could take a quick shortcut maybe, but none of them are. So, and there, I don't see any greatest common factors that I can take out either. So it looks like we're going to have to resort to factoring by grouping. So I do 12 times 5, which is 60. And then I got to find 2 factors of 60 that add up to 23. That's 20 and 3. Now, I skipped some of those factors, but add them together, you still get 23, right? So the 23 w's, I'm going to split up into those 2 groups, 20 w's and then 3 w's. But then we still got the rest of it, so it's a 12w squared. That was a positive 20w. And then we got the plus 5 on the tail end there. Okay, so we're looking at factoring by grouping. Again, it does equal 0, but I'm not worried about that right now. I'm going to factor from this first group. It looks like a 4 and a w. So what am I left with? Well, 12 divided by 4 is 3. W squared divided by w is just an individual w. And then 20 divided by 4 is positive 5. And then the w we factored out. Now this next one, it's actually already set up as 3w plus 5, right? So on this one right here, that means that I'm going to need to show that I have factored out a positive 1. Because everything divided by 1 is itself. And I want that plus 1 there, so I have something to stay there after I factor out my 3w's plus 5. Okay, so what do I have left? Well, I have the 4w's, and if I didn't have that plus 1 there, then I'd be like, what the crap do I do? But I have it, so I now know what to do. So this all equals 0. And that's pretty good. That's pretty good so far. But we're not done yet, so we got to finish with a little bit more space. And yeah, we're going to make that 3w plus 5. If I could get it to equal 0, would be good. So I'm going to. Okay, I'm going to solve this, subtract 5 from both sides, 0 that out, drop my 3w's, which equals negative 5, and then finally divide both sides by 3, and I get w is negative 5/3. Okay, now if you go back up here, you could use this equation, you could even use this one. Remember, this was just negative 5/3 is to make this equation equal 0, but we had several different equivalent equations throughout. This one, and this one all equal to 0. The one we really want to check is this one, though. So always go back to the beginning equation to check, because if it's false, you may have just made a small mistake somewhere in between here. Again, you could check here, you could check here, but really you want to check in the beginning, okay? So let's see what I get. I'm going to replace the W with negative 5/3. I'm just using the calculator. Negative 12 parentheses, negative 5/3 close parentheses to the power of 2. Oh, it's kind of ugly, but it's going to work. On the left side, I got negative 100/3. And again, I got a question mark over my equal sign because I don't know if it's going to be equal, because I could have made some mistakes. But then I'm going to take my 4W. Ah, man. 4W plus 1. 4W plus 1. If I could get that to equal 0, I'd get a true statement as well. So let's take that and solve it. Okay, so subtract 1 from both sides. That's going to 0 that out. Drop your 4W's equals negative 1. Then divide both sides by 4 to make it a 1W, phantom 1, equals negative 1/4. Yeah, thank you. I do need to check the right side as well. You know what I'm saying? So, okay, so 20/3. I got to check that one. 20/3 times negative 5/3 plus 5, enter. It gave me a decimal, but I changed it to a fraction, negative 100/3. And so that confirms that I went back, negative 100/3 there. I went back and checked the negative because I could have checked on the right side, but I didn't. That was true. That was true. And now I can box that in with confidence knowing that I have found that as a solution. But now I need to check both sides with negative 1/4. I'll try not to forget the right side on this one, though. So negative 12 parentheses, negative 1/4 to the power of 2, enter. And on the left side, I got, so I'm checking this again, right, with my blue answer. We got a negative 3/4 on the left. Okay, so 20/3 times negative 1/4 plus 5. And I got negative 3/4 again. So it was true when we checked the first answer, which was negative 5/3. It was true when we checked with W equals 1/4. So we have both solutions right there. All right, you're gonna see something like this, and some students get this mixed up. They're like, all right, negative 4 and negative 11, and that would be great if this equaled 0. But it's not 0, it's negative 10. So what we gotta do, we gotta go back a little bit and do some FOIL action. We gotta change this back out of its
What was that? I didn't hear you.
tinfoil hat action. So it's we gotta go back, we gotta distribute, and then we gotta distribute, and then we'll make it equal 0, okay? So that'd be first distribution, h times h is h squared. H times 11 would be 11 h's. I'm using one color here, hopefully that's okay. Then 4 times h is positive 4 h's. 4 times 11 is positive 44. Now this does equal negative 10. Sorry about my handwriting, by the way. You could look to combine like terms at this point if you want. The 11 h's plus 4 h's is positive 15 h's. That's nice. So writing the rest of this, we got h squared plus 15h plus 44. So distribution, then combining like terms, which is what we did. Now we're going to use principles of equality to force this to equal 0. I'm going to make it 0 on the left because then I just got to 0 out the negative 10. So I'm going to add 10 to both sides. This plus 10, I do have a like term on the right side this time to combine it with, though. Negative 10 plus 10 rather is, well, 0 like we planned. Then this equals h squared plus 15h. And then I got 44 plus 10, which is positive 54. Oh, yeah, thank you. So the good news here is that I'm going to skip the factoring by grouping because the leading coefficient is 1. So yeah, we need the two factors here of 54, right? Since the leading coefficient is 1, we're going to split this up into two binomials with h. But we just need the two factors that add up to 15, right? Yeah, and it's, 9 and 6, right? And that's a positive 9 and a positive 6. Now remember, this still equals 0. So these equations are going to be great to solve. So like the h plus 9 right there if it could equal 0 by itself, it would make the original equation true, so subtract 9 from both sides. H then would equal -9. Okay, so replace H with -9 up here at the top. -9 plus 4 is -5. -9 plus 11 is 2. -5 plus times 2 is -10. That checks off. Okay, so I'm going to box that in so I can put that behind me. And then we've got the other binomial, h plus 6. If we could get it to equal 0, it should give us a true statement. So subtract 6 from both sides, and zeros that out. H then equals -6, right? Okay, so let's go back and check. If you replace h with -6, that'd be -2. This one would be +5. -2 times 5 is -10. That checks off as well. And we have our two answers. All right, so just make sure you read these. We're not really concerned about the rocket part of it, but here we go. A rocket is launched at t equals 0 seconds. That's nice. Its height in feet above sea level as a function, t, is given by this function. So thank you for the function. Some of that information is pertinent if you were to do some more stuff with this, but we're not, okay? By the way, this one, it looks like it was launched at a height of 528 feet. How do I know that? Because I replaced the t's with zeros. That made it easy to solve. H of 0, that's time is 0 seconds, 528. There we go. I also suppose you didn't care, so maybe I wasted your time. When does the rocket hit the ground after it is launched? Okay, well, we got to ask ourselves probably, we may have to ask ourselves another question here. When does the rocket hit the ground after it's launched? So it's going to hit the ground, right? Now, we have two things that this function is based off of. T is time, h is height. So we have to ask ourselves sometimes, how high off the ground, I'm not trying to be a jerk here or facetious,
It just happened.
is the, yeah, I know. That's what happens when you're around 12, 13, and 14-year-olds all day long. How high off the ground is the ground? Well, last time I checked, it was 0. It was 0 feet off the ground, okay? Why is that important? Because my height right here, I'm looking for it to be 0. So it's related to everything we've just done in this lesson, which means that at this point, you just say, well, we're just pretty much factoring this equation then? Yeah. We're going to factor, it's already equal to 0, so that should be good. So something else that I noticed right here, and some students may not notice this, and so they go straight to factoring by grouping, which is a legitimate way to do it. And you would get the answer. You should get the same exact answer that I do. But I noticed that at least all these numbers they're even. So they're divisible by 2 at least. I think they're all divisible by 16. I think. So why is that important? Because from that, if I factor out, well, really -16
And
from
that's
this.
because you have to switch.
And it's not like I know my multiples of 16. I'm just, just checking the calculator. 128 divided by 16, which we're going to do anyways, I guess. 128 divided by 16. Really -16, right? So that ends up being a -8t right there. Dang it, -8t. Thank you. So the last one there is +33. Thank you. Now the first one, of course, we're just left with the t squared. Okay, now of course this does equal 0. I'm not worried about that yet, but now I have a leading coefficient that is 1, which is great news because I'm just going to factor this out into two separate factors. What I need then is for 2 factors of 33 to add up to 8. I got it. Well, sorry, -8 rather. So it's an
Isn't it negative?
yes. Make sure you get your signs correct. Try to have someone with you that can help you in case you miss it. It's a -33. Thank you. Now, -11 times, I guess we're still using the same number, so even if I did it wrong, it ended up being right, which isn't really a good thing. But from this, we got the t's in here, and I've got the -11, and then the +3 right there. Now, I'm going to write the rest of this equation out. I'm gonna do something probably no one would do, But the negative 16 is obsolete right here. It doesn't make any difference because everything else is going to be 0, right? We're going to make this factor 0 and this factor 0. So the negative 16 doesn't matter. I'm going to force it to not matter, though. How am I going to do that? I'm going to make it a phantom 1. If this doesn't help, ignore what I'm saying, okay? But I'm going to use the principle of equality by dividing both sides by negative 16. What does that do? It makes that a phantom 1. And then I'm left with just t minus 11 times t plus 3 equals, well, what's 0 divided by negative 16? It's still 0. So it just gets rid of that negative 16 for us. It was a little extra step. It's a little extra work. Is it worth it? You have to decide, though. Okay.
I'm sorry.
If you could factor out a t from the 3 terms, then that would have made it a little bit different, but we couldn't. So there you go. All right, so let's rewrite this because I need a little bit of extra space, right? So I got 0 equals t minus 11 times t plus 3. And if I could get that t minus 11 to equal 0, I'd get a true statement. So, yeah, and so yes, not everyone needs to show this work. Just be careful doing stuff in your head. As you see, and I make mistakes. So t should equal 11. Okay, so I'm going to go back to the original equation and check. Okay, so that was negative 16 times, now it's 11 squared, plus 128 times 11 rather, plus 528, enter. I got 0. So this one checks off, right? T equals 11. Oh, that's good. Now I'm going to solve t plus 3 equals 0. So I'm going to subtract 3 from both sides, zero that out. Drop my t equals negative 3. Now, will negative 3 work? Let's see, negative 16 times parentheses negative 3. I want that in parentheses because it's negative squared plus 1, yeah, or times 9. Plus 128 times negative 3 plus 528, enter, boom, it's 0. I'm not going to box that one in, though.
Because those aren't answers. Oh, you just ignore that one, right?
Yeah.
Because it's not going to be negative height.
That's correct. So on this one, this is a word problem. It has to be applicable and actually make sense in the problem. In fact, this answer right here that I have is 11. It's good, it's just, it's not 11, it's 11 seconds. I'm just gonna put 11s, S for seconds. But you can't have negative time. Well, I guess you could, but that'd be really
No,
weird.
it's seconds, I'm sorry.
Seconds, right
Oh.
there. So you could say negative 3 seconds would work, but that means it would be 3 seconds. It would be at, it would have been at the ground height 3 seconds before you launch the rocket. Yeah, launching the rocket. But
Technically, it probably was on the ground 3 seconds before. If was
it may have been, yeah. So, but in any case, that is it. We only have the one answer on this. All right, the long leg of a right triangle is 7 feet longer than the short leg. Okay. A quick reminder, because they say it's a hypotenuse. That's important too. And then they said their legs. We're looking at a right triangle here. I think I can get one with the technology. So here's my right triangle, which is pretty because I use technology. That's a right angle mark that I just put in the bottom left there. The two sides that make up the right angle are legs. So there's a leg in red and there's a leg in purple. My green side for me is what they call the hypotenuse. Key and Peele did a decent skit on it. So if you like it, go watch it. But
Pythagorean Theorem, man.
in all the most unlikely places, we have found Pythagoras once again. But he did choke out a dude for questioning him on things, and it didn't turn out very pretty. He killed him. Also, he ended up having a lot more power than you'd want probably one person to have. In any case, we have the long leg of a right triangle. I don't really care that it's longer, but we see that it's 7 feet longer than the short leg. That's kind of crucial. So what I'm going to do is I'm going to formulate a variable here myself. I'm going to make it x. You can make it whatever you want, but I'm going to use x. I'm going to say that's the length of the short side, the short leg. And I guess since I'm doing it in red, this will be my short leg in red, even though it appears to be longer than the purple one. Okay, so the purple one will be my long leg then. And it is related to the short leg. So you could take the short leg, but it's 7 feet longer than that. So that's my longer leg right there. Then it said, in addition to that, the hypotenuse is just a straight 13 feet, looks like. Well, I made this colorful and it's pretty, but we got to go back to the Pythagorean theorem, okay? Now I'm going to do this, well, I'm going to do it a little bit different, okay? So you take, yeah, you're going to, well, yeah, you can use the abstract on this one. Yeah. I'm going to show it a little bit different, just related to the words that they're using. Oh, hypotenuse. Okay, so we got 2 legs and a hypotenuse because it's a triangle. If you were to square the legs and then add them together, you'd get the same thing as the hypotenuse as a square. And when we say squaring, we're literally talking about if you were to make squares out of those side lengths, the area of the 2 legs as squares would be the same area as the hypotenuse is a square. Okay, so we have the values though. I know the hypotenuse is 13. Uh-oh. Technology. My first leg, in red, it's just x. And then my longer leg, in purple, was x plus 7. Okay, so again, applying the Pythagorean theorem, I really don't need parentheses around that first x, just x squared. But the longer leg, I do need the squared on that one. And then the hypotenuse also is a square. So we can see that this is setting up, it will set up eventually to be a trinomial. We just got to get to that point, okay? And we need it to equal 0, just like we've been doing. So on this one, I'm going to show x plus 7. So I'm going to show probably more work than you want me to do, but I'm still going to do it. Okay, so that's x plus 7 to the power of 2. It's x plus 7 times x plus 7. And then some distribution, or FOIL, gives me x squared plus the 7x's. And then more distribution plus another 7x plus 7 times 7 is 49. Okay, now I still got the other x squared. And I do need all this stuff, by the way. And this equals, I'll evaluate 13 to the power of 2 right now. In the calculator, 169. Okay, so that is, it's the distribution part of this. Now that we've done distribution, we're going to look to combine any like terms. I've got x squareds. How many of them? 2. 1, 2 of them. And then I've got x's, which I can combine. How many x's? 7 plus 7 is 14. Then I still got the plus 49. And this equals 169.
Which is 120.
So yeah, now we're going to force that to become equal to 0. So minus 169. Minus 169. So that's going to be a negative 20 right there. Equals 0.
120.
Oh, thank you. That would have been disastrous. But we got it, so 2x squared plus 14x minus 120. Sorry, that's kind of an ugly 120, but I did jack it up. Okay, now at this point, we have a trinomial equal to 0, which is what we want, but I also see that I have a leading coefficient of 2. 14 is even and 120 is even, so I'm going to factor out that 2, okay? I'm going to factor out a 2. The first term is going to leave me with just the x squared. 14 divided by 2 is 7. That's how many x's I got. And then negative 120 divided by 2 is going to be negative 60. This should still equal 0, which it does. Now, in factoring this, I don't really care about the 2. I'm going to skip this. So the last problem, I kind of got rid of it like the negative 16, right? I'm going to keep it this time just to show you that you can. And we're going to factor this trinomial into 2 binomials, okay? So everything else stays the same. I know I'm going to have x's as my first term in both binomials, but I need 2 factors of negative 60 to add up to 7, 3, 15, 12, and thank you. Is it positive 12 and negative 5? Thank you. So that's plus 12 and negative 5. Remember, I'm not using factoring by grouping here because I'm taking that shortcut that we saw in, what was it, 4.3, thank you, maybe 4, somewhere in there. Now again, if I just need these 2 factors to equal 0, which is why the 2 does not matter. And so in solving these, if I can get x plus 12 to equal 0, that'd be good. So I'd subtract 12 from both sides and get x equals negative 12. Okay, now Okay, so x is negative 12. I'm going to leave it at that, but I'm going to come back to it, okay? If I can get x minus 5 to equal 0, then I would get a true statement here on this equation, which should be the other one as well, but adding 5 to both sides means x should equal 5. Now, just like the last problem with the rocket, here it's saying that x is negative 12. Now, if you say x is negative 12, that means we have a negative length. We should not have negative lengths. So that means that this one is invalid right off the bat. Would it make this equation true? It would. It doesn't help me because I don't want a negative length on a triangle. I don't even know how you'd make that look.
Inverted.
You could take the absolute value, but in any case, let's go back. Okay, so it says how long are the legs of the triangle? Well, I know the short leg is just x. So this 5 right here, that is the short leg. By the way, it's not just 5. It's 5 feet. Yep. Don't forget to label these because on a test, I feel bad. But that's my short leg. Okay, so and if the short leg is 5, we know the long one is just 7 more than that. So the long one would have been 5 plus 7, which would have been 12 feet. Now these two should work. If they do work, then 5 squared plus 12 squared is 13 squared. It is. You'd have 25 plus 144, which is 169. It works. So that's my two answers right there. You'll notice that the negative was negative 12, which is kind of told us what the other value was. But we just make sure you put it back in. Make sure it actually is 7 more than the shorter leg if you set it up like this. All right, the length of a rectangle garden is 8 feet longer than the width. If the area of the rectangular garden is 20 square feet, find the length and width of the garden. Okay. Well, let's take a look at what this garden looks like. It's rectangular, so let's see if we can draw a nice rectangle here with some technology. Okay, so that's our rectangle. I really don't care if it's proportional, but here's what we know is that the length is 8 feet longer than the width. Okay, now right off the bat here, I can write a little bit of an equation here based on that expression or that the words it gave me. The length is the same as taking the width, but then adding 8 more to it, okay? So everything is in relationship to the width. L for length, W for width. So over here, I say this is my width, and this is my length right there. Why is that important? It's because the area of a rectangle is the same as taking the length and then multiplying it by the width, okay? I've given myself some separation there because I'm going to fill those in. But here I have length as L, but I can change that into this expression W plus 8, right? Because that's the same as the length. So that's what I'm going to do. I'm going to make it in relationship to the width. The length is the width, but 8 more than that, okay? So over here in the formula, well, they did give us the area. It was 20 feet. And this is going to equal the length, which is, again, it's going to show as the expression, the width, but 8 more than that. Then, of course, this is still being multiplied by the width, okay? So this is my equation that I got to solve for both the length and the width. But you can see I now have an equation that just has the width inside of it. So when I solve this equation, I will have the width. And then in addition to that, by distributing the W, I have W times W, which is W squared. Some students say, well, can you distribute from the right? Yes, distribution is just multiplication, so it doesn't matter which side it's on. And then I have W times 8, which would be 8 W's, okay? So this is my new equation, 20 equals W squared plus 8W. But I can see that this is kind of forming like these exponential equations that we've been looking at, these quadratics. These trinomials, that's the word I was looking for. So what I'm going to do here is I'm going to make this equal to 0, which is going to allow me to solve for W with some factoring, right? So that's going to be 0 right there. I've zeroed out my 20 on the left. Now I have the equation W squared plus 8W Now again, those are not like terms that I can combine, and I can't combine either of those with my negative or minus 20. So this is my equation right here that I need to now solve. And so what I'm going to do is I'm going to take that, and I see that my coefficient of w squared is 1. So I know I can split this up into two binomials. I just got to figure out what two factors of negative 20 add up to positive 8 right there. So let's see, 2 and 10. 2 and 10 do work. I was thinking maybe something, well, not 4 and 5 don't work. And yeah, I guess that's all of them, right? So I'm looking at 2 and 10. Now you say 2 plus 10 is 12, though. That's true. I need them to add up to positive 8, and when I multiply them, I need this to be negative 20, right? So this would be, it's positive 8, so I'm going to make the 2 negative right there. So it would be w minus 2, and then w plus 10 right there. And that's what would equal 0, okay? All right, well, that's fine, and we did some factoring right there. It was pretty, it's fun, it's colorful, but what does this tell us? Well, this tells us, I'm going to take a bit of a shortcut right here, that your width right there in the first parentheses, it could be 2, but the second parentheses would tell you that the width could be also negative 10, all right? Now, if we are looking at w for width, if I put some labels on this, I hope I can emphasize my point right here, okay? If you were to look at these 2 feet and negative 10 feet, which one would you say would be the width? Well, hopefully you know that you can't have negative distances or lengths, so it can't be the 10 feet. The width must be 2 feet. Okay, now, since we know the width is 2 feet, and that's good, we know that the length is like taking the width, which we see as 2, and then just adding 8 more feet to it, and that would then show the length as 10 feet, okay? So, the width, 2 feet, the length, 10 feet, right? Now let's go back and check, okay? So just with these two values, is the length 8 feet longer than the width? It is. 2 plus 8 is 10. The other thing we have to check here is the area of the garden. Is it actually 20 square feet under these measurements? 2 times 10 is 20. Yeah, that checks off for both the width and the length. Be careful not to mix these up, because I believe if you put the width is 10 feet and the length is 2, it would mark that wrong on the assignment. So just be aware. All right, how about this rectangular picture right here? Well, that's a nice rectangular picture. Let's see if we can draw a picture of it. Sorry about the pun. But this one says that the length of the rectangular picture is 4 times as long as the width. Okay, so again, I know that my length is the same as taking 4 and multiplying it by the width. The width, of course, is just the width. The other thing I know is that the area of a rectangle is just the same as taking the length and then multiplying it by the width. Okay, so looking at this picture right here, of course, we have width and we have length, but if I kept it this way, it doesn't really help me. I want to show that the length is 4 times as long as the width. Okay, so over here, the length, just like we've shown in the equation there on the left, I'm going to replace it, instead of showing it as L for length, I'm going to show that it's the same as taking 4 of the widths and multiplying it 4 times the width, okay? So in my formula for area, right, it says over here, there the picture is 100 square inches, so that's a 100 equals the length. But now my length, I know, is 4 times the width, and then that still is multiplied by the original width, okay? Now to simplify this, I now have 100 equals, I got 4 times W, right? All that together is still multiplication, but it's 4 times W to the power of 2. And you'll see why that's important here, because I'm going to solve this like I would one of those other equations. And so I'm going to get rid of that 100. I'm going to make it a 0, right? So I'm going to make it 0 equals 4W. I'm going to drop that 4W squared. And you see I subtracted 100 on the left, so I must subtract it on the right as well. So I got 4W squared minus 100. Well, why is that important? It's because 4 and 100 are perfect squares right there. So what I'm trying to do here is I see that I have a difference of squares. So I'm expecting an addition and subtraction binomials on this. Of course, it still equals 0, right? So what is it that's being squared? Well, from the 4w, that'd be the same as taking 2w and squaring it. So I know that's my first value is a 2w in both binomials. And then 100 is the same as taking 10 and squaring it. So it'd be 2w plus 10 and then also 2w minus 10. These two binomials are being multiplied together. But again, that still equals 0, right? So I got to take the 2w minus 10. Perhaps this is more work than you'd want to ever show, but I'm going to show it. So 2 times the width plus 10. If I were to solve this one, because remember, if I could just make that equal to 0, then that would make the full equation true, right? So I'm going to take that, I'm going to subtract 10 from both sides. Drop my 2w, we zeroed out the 10s. 2w equals negative 10. And then divide both sides by 2 to make the width, it could be negative 5, right? Now, I said that out loud on purpose so that you could understand how that's going to work, whether you did or not. We now have a second binomial that we should check. So that was saying that if 2w minus 10, if we could get that binomial to equal 0, then it would still make the equation true, right? So we take that, and we're going to solve this one as well by adding 10 to both sides. Drop the 2w, the negative 10 zeroes out, and that now equals 10. And the last thing we got to do there is divide both sides by 2. Okay, so the width, it could be negative 5, or it could be a positive 5 inches. So I'm purposely labeling these just so you can see exactly what's happening. We can't have a measurement that is a negative length right there, or width in this case. So that one can't be the case. It did want the width and the length though, right? So right there, it's okay, I do have my width. But here's what I notice is that the length is 4 times the width. So I'm going to take my length and I'm going to make 4 and multiply it by the width, which is 5. Okay, which should make the length 20 inches. Okay, now if I've done this correct, then I found my length and my width. Does this work though? Well, 20 inches is 4 times 5, so that takes care of the first condition. The second condition says that the area should be, of the picture, it's rectangular, should be 100 square inches. So 20 times 5 is 100, and then it checks off both conditions, the only 2 conditions that it gave me in this problem. If I didn't get 100, or if I didn't get that the length was 4 times the width, then I'd have to go back and redo some things. But this one checks off, and now we know we've even labeled them, right? So we're in good shape right here. This problem's good.